My name is Michał, I work at Untitled Technology, and I want to talk about functional programming in Java and Scala. And I will mostly show Java code here, but I also want to show you some Scala snippets so that you can compare side by side. And I will be honest, this is a talk about functional programming, but I don't want to show you any math here, and I don't want to explain why monad is a monoid in the category of endofunctors. I don't want to convince you that functional programming is cool either. What I want to show you is some practical and applicable examples so that you can include functional programming in your tool belt. So imagine that you are part of a remote team that does contracts for various clients around the globe. And one day, a new client approaches you, and he's from galaxy far, far away, and he heard about this thing called Twitter that people on Earth use, and he wants to have something like that in his own galaxy. So you, of course, happily accept the contract and promise to have a working prototype by the end of the following week. And of course, you immediately go to your favorite coffee house and start hacking right away. It turns out that the main functionality, MVP functionality, is to have a followers functionality. That means your application needs to be able to show for each particular user how many followers does this user have. So you spawn your IDE, and because you are programming in the coffee house, you want to use functional programming, right? And what does it mean to be a functional programmer these days? Many of you probably know the answer to this question. Usual answers are using immutable collections, creating immutable types, reassignments, or avoiding reassignments, functions as first-class citizens, and of course, functions that take functions as parameters and return functions that means higher-order functions. And we have lambdas and streams since Java 8, right? So we can program functionally. Is that correct? Well, yes and no. Yes, lambdas helped a lot to bring functions as first-class citizens to Java, and streams are a higher-order function API, but they are a little bit verbose, but it's still a big step forward. However, the main problem is that the rest of the APIs haven't really changed. So we still have immutable collections, and we need to use Guava or something like that in order to have immutable collections. And of course, we still need to use Lombok and things like that in order to create immutable types. So streams are nice additions, lambdas bring functions to the language, but the rest of the APIs hasn't changed. The same thing cannot be said about Scala. So in Scala, everything is built into the language, so immutable collections are built in. We have case class that helps us create very easily immutable types, and of course, higher order functions are less verbose than in Java. And in Kotlin, in terms of basic functional programming, Kotlin and Scala are very similar. There are some differences on more advanced levels, which I will touch upon at the end of the presentation. So they are very, very similar. But I'm not here to talk you into Scala or Kotlin. I'm here to talk about functional programming, and it turns out that we can program functionally in Java today. There is a library called Waver, which has been just renamed from Java slang due to trademark conflict with Java, of course, and we can do very basic and very helpful functional programming stuff in Java today. So all my Java code today will use Waver. So in Waver, immutable collections are built in, functions are built in. There are wrappers around Java functions, and higher order functions are less verbose. Yeah, less verbose than in Java. We can really use the collections API, which is immutable. And there are still some hiccups, like we need to create immutable types by hand, but it's still a big improvement over what we have in Java 8. So a small disclaimer, I'm a Scala developer, that's why I picked up Waver very quickly, but if you have any problems, please interrupt me and I'll try to explain the code. There will be lots of code in the presentation and live codings and so on, so just please interrupt me and I'll try to explain better. So after including Waver, we have almost all things we need in order to really program functionally in Java. And remember, we were tasked with creating a new galactic Twitter application with the followers functionality. Okay, so let's try to use it in a real project. First, our domain. So for the followers functionality, we need to have a model for the citizen of the galaxy. So this is the abstract class, normal Java abstract class, just a name. So abstract citizen has just a name. And then we have some all possible concrete subtypes like civilian with a name, Jedi with a name, rebel with a name, Sith, of course, and finally stormtrooper, which has also a name, but additionally it has its cloned flag which tells us whether this particular stormtrooper is a clone or not. So that's our domain. And we also have a way to fetch those guys from database. So there are two functions. First, in the first function, we provide a string with citizen name and get the citizen back. And the second one is followers, getting followers from the database for the particular citizen. And this is implemented by some of our colleagues, so we just use this as an interface. The most important thing, however, here is that both of those functions return future. And this is a future from Waiver, not Java. And a future from Waiver models a computation that will provide a value in the future, or it will fail. So this is the foundation for asynchronous programming. So what can we do with such a type? This is future of something that we are dealing with. So we are backend developers, so we'll try to create a console application to test our stuff besides the REST interface that we need to implement. So our console application looks like that. We need to get then the line input, console input. Sorry about technical problems. Yeah. So again, we are getting the name of the citizen from the console input, and then we are using DB client get citizen by name with the provided name, and then we are pressing dot period in our ID and see what can we do with this crazy future type. And one of the things we can see is get. Get, what it does, it just unwraps the value from the future. So let's do that, and let's repeat the same procedure for getting the followers. And we are able to print the followers to the console. So we have done well, right? We have done well, or did we? So is there any problem here? Sorry? Yeah, thank you. We are blocking. So when we run this application, we can see that that the user thread is blocked. It's blocked because we are waiting for the value to become available, and only then we can proceed with the execution of the program. So we should be keeping the user happy by not blocking at all. So let's try to do that. Let's get rid of the blocking call. And it turns out in functional programming it's very common, a common pattern to deal with such problems. We are just not unwrapping anything from the context, in this case, the future context. What we are doing is we are applying the data transformations using the map operator, map function. This map gets a function that will be applied to the argument inside the context, and we are doing it until we need the final value, and only then we are trying to unwrap it. And there are some other solutions to that, but still we are trying to stay in the context as long as possible. And in this case, we'll get future of the future. So in order to solve that, you will use flat map. Flat map is just map followed by a flatten. And flatten, what it does, it just converts future of future into one future. So we are flat mapping all the way in order to get the future of integer here in line 108. Okay? And this pattern of mapping and flat mapping is so popular and it's so common that in Scala, those snippets here on the slide are doing the same thing. So in Scala, at the bottom, you can see that we have a language syntax just for doing mapping and flat mapping. It's called for comprehension. So this is included in the language. So what can we do with this function that returns future of integer? We need, in order to even show it to the console, we need to have this integer, not future of integer, right? So what we need to do is we need to somehow be able to get this value and show it to the user, and we still don't want to block even in this user client call. So it turns out that future in Waiver has this nice method called for each, and for each takes a lambda, and this lambda gets executed whenever the future completes successfully. So only then our line 23 will get executed, which is the update of the cache, and until then the cache will return the cache will return the default value, which is defined in 25, which is 0. Okay, so user will need to poll the part of the contract. Our assumptions about the API is that the user will need to poll every now and then in order to get the current value, but the code is not blocking, so that's a trade-off. And we have used hashmap from Waiver, not hashmap from Java, and hashmap from Waiver is immutable. So put operation returns a new hash map. Also, get operation returns an option. An option is a type which has two concrete subtypes. One of them is sum when the value is present, and second one is none when the value is not present. That's why it's very, very nice to model it using options. So get key can be in sum or none. So this is an additional thing we use from Waiver. And now the user can use this application as we intended. And so 0 followers, but a third call is 102 followers. So yeah, polling needs to be included in the API. But we have several threads, and we have no logs. We have no spawning the threads by hand, immutability and future. This is the power of them, okay? So this was just a helper application, but there's another colleague of ours which is implementing web application based on the API we provide. And he just did something like that. So polling every 200 milliseconds as intended, and yeah, updating the value on the GUI regardingly, okay? So this is our application. So we have done well, and everything works fine, but one night, our telephone starts ringing, and it's our client, and he's not happy, and he files a bug report. I have 0 followers, it's not possible. Okay, so we run to our desk, of course, we need to be running to our desk, and fire up our console helper application. I'm glad that we really wrote it, and then run a query against production database, because why not? And we can see that, yeah, Darth Vader has 0 followers, Darth Vader has 0 followers, 0 followers, and only after 10 or so seconds it converges to the real number. And we know that Darth Vader is not so patient. So we need to fix that. But what happened? What do you think? Yeah, so database is slower. Production database is slower than we thought. And so this is the problem that we need to address, of course. But the real problem in our application is that we are treating 0 as 2 possible things. One of them is 0 followers, obviously, and second one is there is no value yet. So that's the problem here, and we need to deal with that. And in strongly typed functional programming, what we do is we are modeling everything with data. So we are modeling our assumptions about the API using types. And in this case, we can change the signature of our function to have an option return type, because option models value that may or may not be present, right? So let's do that. Let's change the implementation that we've had so far. So we can see that there are not many changes. The only one is in line 33, which is integer change to option of integer, of course, because that's what we wanted to do. And the second change is line 37, which is we got rid of get or else. So right now we are just returning the hash map get, which is an option, and that's all. So not much change in the implementation. And our web application needs to be updated accordingly. So we can see that when none is returned, we get loading. When sum of integer is returned, we just display this integer. So now the user knows what's happening. Okay. So everything works fine. But one night, our telephone starts ringing. And this is our client again, and he's not happy, and he files a bug report. I can't check how many followers does Obi-Wan Kenobi have. Okay, so what we do, we run to our desk, of course, and we fire up a console application, and we run a query against the production database. And we provide the name Obi-Wan Kenobi as Darth Vader provided, and we can see that Obi-Wan Kenobi has loading followers, Obi-Wan Kenobi has loading followers, and so on and so forth. 20 seconds, 30 seconds, 1 minute, 2 minutes. It never converges. So what happened? Turns out that we didn't handle the future failure. So future is something that models value that may be available in the future, but also it models a failure, because the value computation may fail. And for each, what it does, it only executes the lambda we provide when future finishes successfully. So it really won't update the cache whenever there is, for example, an exception. And in our case, there is an exception because our DB client design is not very, very good, because it throws exception whenever the client is not found. Sorry, not client, but the citizen with the name we provide is not found. So that's something that we need to address also. But remember that there also may be some technical problems, like timeouts or other network failures. So we need to handle future failures. So what can we do? So this is, again, a problem that we can address with data with types, because in strongly typed functional programming, we want to model everything as data. We want to model our assumptions about the API, in this case, a potential failure, with return types. And there is another type in Waiver which is called try, and it models just that. It models success or failure. So it has two concrete subtypes, success or failure. And there are some similarities to option. And I will show you how it works in live coding here. So let's see what can we do, what can we see. So this is our application. We can you guys see it in back? Okay, cool. Sorry, IntelliJ has frozen. It's not a good thing. Let's try to. Sorry about the technical problems. Sorry. Yeah, okay, of course. Yeah, force quit. Not good thing to do. Let's try to run it again. So again, what we will going to do is we'll try to have our application and try to handle the failure case in the future. Okay, so let's see whether it works or not. Okay, I'll just try to not use presentation mode, because let's do that. Okay, you can see it? Not frozen. Good. Okay, so this is our application. You can see cached followers. This is the map that we used, string to integer, and our implementation of get followers async. So we are getting the citizen by name and then flat mapping all over. And our console application here is, of course, getting the future, and then for each, we are updating the cache, and then every time the user wants something, we just get it from the cache. So that's how it works. And in order to see the problem, I will just try to code it out and use the synchronous version, because we can see the so that we can see the exception in the main thread, right? So just for a bit, for this particular moment of time, we'll try to use the synchronous version and get followers sync, which is commented. So the followers sync is doing the same thing as async version, but synchronously. Okay, so this is how it works, and of course we need to string it. So that's all we need. Let's see how it works, the synchronous version. So we can see the problem. We can see the exception. So Darth Vader, it's not misspelled version. The problem with Obi-Wan Kenobi was that W was not capital. That's the capital. That's why we failed. So getting followers for Darth Vader is 102 followers. Cool. And Obi-Wan Kenobi misspelled version should throw an exception. Okay. And you can see there is this exception, and pay close attention to this exception, because this is the last time you can see this red big exception, okay? Okay. I will show you a very, very nice trick using the try type. And in order to get rid of the throwing of exceptions, we can just wrap the call that may throw an exception with a runnable, okay? So we can see that something like that is enough in order to deal with the exception. What we are doing is we are using the try type in order to move the exception from the exception mechanism into types. So now our application didn't fail, but we still get this exception as return type. So we are moving exceptions towards the types. Okay? So that's how it works. Cool. And now we can just do the same for the asynchronous version. So we'll just try to comment this out. And the same can be done with asynchronous version. We need to change the for each to onComplete, because onComplete, what it does, it always executes the lambda, but the lambda is executed with tried followers. This means that here, tried followers is of type try. And now we have a compilation error because our cache needs to be updated to have this try of integer. And probably that's all we need to do. So here we can just map it with a function. So tried, those are tried followers, tried followers to string, and then what we need to do is we need to get or else with loading. And then this is all we need to have in order to implement the asynchronous version. So again, option is here, and let's run it. So the whole thing is option of try, and then we just mapping the thing inside option, and we are getting or else. OB1 can OB. Let's see what happens. As you see, it's asynchronous version, Darth Vader, asynchronous version, but OB1 can OB is still updated with the failure. Okay, so this is something that we did using the try. Okay, let's move back to the slides, and now you can see that we just needed to do 2 changes. The first one is the update of the cache. So the string to integer was changed to string to try integer, and onComplete instead of for each, because onComplete executes our lambda whenever the future completes, either with success or with failure. And we can see onComplete from the documentation of Waiver at the bottom. onComplete takes a lambda with just 1 parameter, and it is a try, and it always gets executed. So now we can see directly in the function signature in line 46 what are our assumptions about the API. Option, because the value may or may not be there, and try of integer, because the computation may have failed. Okay, and integer is our count of followers. Okay, the best thing about this new type is that, and other types like that, is that we can pipeline potential failures. Remember that we have 2 futures: one for getting the citizen name, and second one to get the followers. And if we are doing all the transformations inside the context, we need to deal with the potential failure at the end, only when we need the final value. So, for example, here we have 2 potential failures and 1 error handling. If we have many futures, we only need 1 failure handling at the end. Okay? Of course, we can have more if we need, but at least in order to have a resilient application, we need to handle 1. So now we change the API, and we need to update our web application. And as you may have expected, when none is returned, we still get loading. When sum of success of 102 is returned, we display 102 or any other integer. And when some failure is returned, for now we just update the user interface so that the user cannot see the failure. It, of course, needs to go through a UX department, but for now I think is enough. Okay, so everything works fine. But one night, our telephone starts ringing, and it's our client again. He's not happy. He files a bug report. I'm not happy with the return types you use in your application. Okay, then suddenly we wake up, and it turns out it's just a nightmare. Cool, but then we start having second thoughts. Maybe this was a sign. Maybe we shouldn't be using such cryptic return types in our application. But what about modeling everything with data? What about modeling our assumptions about the API with return types? So we want to have a cake and eat it too. It turns out we have something like ADTs, algebraic data types. That's where they come into play. So those are very simple types, plain types. Product type is a type that consists of several types, one of several types. For example, when you create a class with integer, boolean, and string, you just created a product type. That is a product of integer, boolean, and string. On the other hand, sum type is more similar to enum, so it can be one of several concrete subtypes at once. So, for example, Stormtrooper is a product type of string and boolean. We have already seen it. It's just a product type. And citizen is a sum type of either civilian, Jedi, rebel, Sith, or Stormtrooper. Okay, and option is a sum type of sum or none, and try is a sum type of success or failure. So as you see, sum types, ADTs, are used throughout the whole thing. So now we want to model our assumptions about the API using ADT. So we create this public interface remote followers data. This is our sum type, and it has 4 concrete subtypes. Okay, subtypes. The first one not requested yet in line 58. So what it does, it just models something that the value that the user has requested has not been requested on the remote server. Loading, it has been requested but haven't heard from the server yet. Failed, it models the failed case, so the computation stopped and we got some kind of error, and the error message is conveyed here. And fetched is a success case, so integer followers are there, and this models that everything worked fine, perfectly. And now we can change in line 78, we can change the signature of our function from this cryptic one to the new ADT one. Okay, get remote followers, now returns get remote followers data. But then we think about our clients and what can the client do with public interface, empty public interface? What can the client do with that? So yeah, we need to somehow think about that. But before we answer that question, let's find out what can we do in our own implementation, because we have a similar problem. We have try of integer in line 81, and what we need to do is we need to create a new remote followers data based on that. So for example, failed or fetched or something like that, right? So new object based on what type the try is. Okay, so what can we do? And there is a nice technique that deals with that, which is called pattern matching, which is also part of the waiver. And yes, in functional programming, we use ADTs all over, and we use pattern matching very much. And what pattern matching does, it can decompose the ADT. Decompose. So case is for every possible case of the sum type. So in the case of try, we have success or failure, so two cases. And in order to decompose the product type, so the type that consists of several types, we use these extractors with the $sign. And of course, probably not all of you wants to believe me that it's very nice, so I'll try to convince you. And hopefully my IDE won't get frozen. That's why I turned off the presentation mode, because this is probably what's causing the problem. Okay. Cool. So what we have here, when we run it last time, as you see, we got this failure of exception, right? Can you see it at the back? Okay. And when I see Darth Vader again, you can see that I have success of 102, because what I did is I just to string it right here. Okay. That's why we get failure and success. What we want to do is we want to create a string based on real value of try. So that's why we need to change this map here. In order, instead of doing to string, we need to do this pattern matching. So we'll pattern match on try followers, and we'll have two cases. The first case is a success case. This $sign extracts a value and pushes it to our lambda. So the second parameter of case is our lambda. This lambda gets the thing that we extracted. So in this case, it's followers. So what we do is just we to string it. And the second case, in the failure case, what it does inside, it has an exception. And we want to extract this exception, and we get it here. So we just format it and say error and some kind of string here, x to string, okay? So that's what we need to do. And now what we did, we just converted to the try of integer into string based on what's currently there. So as you see, Darth Vader, Obi-Wan Kenobi. This is still asynchronous. Obi-Wan Kenobi. Yeah, we can see error, Java lang exception, but request. So, and Darth Vader should have just 102 instead of success, because we converted it really nicely. Okay, so that's how it works. So presentation mode off, and let's go back to the slides. So again, what we did is we just had two cases for try, and based on that we return our remote followers data here. Okay, so that's not a string, it's for remote followers data, but the concept is the same. So we create fetched for success case, and we create failed, which is both of them are implementing remote followers data. Both of them are created here. So the whole thing, the whole value in line 82 has remote followers data type. Okay. And now we know how to handle ADTs. using pattern matching, so we can handle them in our client code. So we can match over remote followers and have to 4 cases, because this is some type of 4 cases. Not requested yet, loading, fetched, and failed. Based on that, we can decide what kind of string should we display. Okay, and those things, ADTs and pattern matching, are also very common. They are so common that in Scala we have a language syntax for that. So sealed trait is just an interface that can be defined in one file. So now other file can redefine what's in the remote follows data, and pattern matching is part of the language, as you see here. It's very similar, little less verbose. Okay, so everything works fine, but one night our telephone starts ringing. And this time, it's not our client, it's our user. And it turned out that our application has become very popular in the Galaxy. It's so popular that it started to be used as propaganda tool. And the followers count of Darth Vader is very, very problematic for our user, which is who is part of rebellion. And he says that clones should not be counted as followers. And we go to our code and we can see that we just return the followers list size. So clones are basically counted as followers. So it is a bug. User is right. So let's fix it. And in Waver, the list has this nice method count. This method count, what it does, it takes a lambda, and this lambda is executed for every element in the list. This lambda needs to return Boolean, true or false, based on the element, and all the truths are counted and then returned. So in order to implement the lambda that we need to provide to the count, we need to decide how to count the citizens. So if it's a civilian, Jedi, rebel, or Sith, we need to count them as followers, but if it's a stormtrooper, only the one that is not a clone should be counted as followers. So what can we use? What technique can we use in order to implement that? That's a question for you. We can use pattern matching. Again, so followers.count, there's a lambda, right? Lambda input parameter f, which is a follower, potential follower. And then the first case is that it's a stormtrooper with a in line 18 with a flag is cloned equal false, right? And any other case, line 19, any other case, default case, we just return true, and that's all we need to have. That's all we need in order to implement the functionality. And of course, this is how it looks in Scala, almost exactly the same. Instead of dollars, we use this underscores, but that's all. So again, everything works fine, but one night, our telephone starts ringing, and it's our client again. He's not happy, and he files a feature request this time. He's not happy because Galactic Twitter is used for political purposes. So we run to our computer and see the Galactic Twitter application and scan through all the tweets, and we can see that, yeah, some of them are rather political. So okay, let's implement the feature for our user. And the user suggested that the feature should be called censorship module. So we want to create a censorship module which should make the Twitter less political. Okay, and the first requirement is that there are a list of filters. There are a list of filters that the user provides, which can change, of course. And one filter, which is highlighted at the top, consists of condition. So whether the filter is applied to the tweet, and the condition is, if the condition is satisfied, then the tweet is manipulated with the manipulation algorithm. For example, if the tweet is pro dark side, then we should add more dark side to it. This is some kind of censorship module. Of course, we also have seven more filters, and the thing is that doesn't matter for you right here. There are just 8 rules which can change. The most important thing is that we can't manipulate one tweet more than 2 times. So we need to take that into account. So this is the initial list. And our first approach would be just to use an if block, right? So we need to have every condition is just an if, and we need to keep an eye on manipulations. So those are just 3 rules, 3 filters. This is the whole 8 filter block. So this is one big block of code with mutable state. And can we do better than that? What do you think? No? Yes, we can. So in strongly typed functional programming, what we want to do is we want to use data to model everything. So we want to use data to model our algorithms. And in this case, we can model sensor filter, the one filter from this list using data type. And this data type has just two fields, two function fields. The first one is the condition should manipulate, is a function from tweet to Boolean, so a predicate, and the manipulate, which is a function from tweet to tweet, which manipulates the tweet. And this kind of class can be implemented in Scala using just one line at the bottom using case class. So that's the same thing. What can we do with such type? We can create a list of it, right? Because it's data type, so we can create a list of data type. So this is the whole list of the initial list of the filters that Darth Vader provided, 8 filters. This is real Java code. I'm not lying here. So look at those and thens and nots and so on and so forth. This is real Java code. No tricks, no compilation problems. It's more readable that way, right? Because we have everything we need to know right here, and it's just the data. But if it's just the data, can we execute data? Can we execute a list? Well, it turns out we can, and the technique is called folding. It's called folding because we are taking the list and we are folding it into one value. So in this case, the approach would be we have this original tweet, and we just pass it through the list. And for each element of the list, we are just folding the current element, current result, current tweet with this sensor filter, and so on and so forth. And we are using this function tweet filter to new tweet for each element of the list, and we get an output value censored tweet. So this is something like that. And in order to give you some perspective, let's see an example on ints. So folding a list of ints looks like that. List is a 3-element list, 4, 6, and 3. And the function that we use in order to fold 2 elements into one is function result x, which returns a sum of result and x. So initially we have 0, and then we process the first element, 0 plus 4, then second element, 4 plus 6, and third element, 10 plus 3, and we get this folded list value 13. So this is how it works. And in waiver list, we have something like fold left. Fold left, it's going from the left. It has 2 parameters. First one is the initial value, in this case 0, and second is the function by function, function2, function that takes 2 parameters, one for the aggregator and second one for the currently processed element. Okay, so what we have is we have a program which is a list, an initial value, and the folding function, and we have a compiler or the virtual machine, which is our fold left execution. Okay, so that's kind of thinking. And in our case, what we can do? In our case, we need to have this function 2, which is called apply filter, and we have this tweet and filter. If filter should manipulate applies to the tweet, then we return a new manipulated tweet, else we return the current tweet. So we are getting this original tweet initially, and we are going through the list, folding the list using the function, and we get the sensor filter at the end. And of course, we need to keep an eye on manipulation, so it gets a little bit complicated, but it's still just 7 lines of code, right? And that's all we need to have. So sensor status is our new type, which contains the tweet and also contains the manipulations. At the beginning, it will be original tweet and 0 manipulations. And yeah, line 103 changed a little bit because it now needs to have 104 status manipulations check. And that's all. Only then we return a new sensor status with manipulated tweet and incremented number of manipulations. So everything is final, no mutable state. Folding allows us to have state without any mutable variables. Okay, that's how it works. And of course, this is the one big block of code now is changed into 2 lines of code. The first one is creating sensor status with original tweet and 0 manipulations, and the second one is just folding over the sensor filters list with initial status and apply filter function, which is defined at the bottom. This is one I've shown you just now. So that's pure functions in full glory. It's so nice that we can even have a feature switch for that. Because when rebellion starts winning, right, the user probably will come and try to find another list of censorship modules, maybe an empty one. Let's hope so. But we can just change one line of code and have a feature switch implemented right there. Just a list changes, nothing more. Okay. Again, everything works fine, but one night our telephone starts ringing. It's not our client, it's not our user, it's Uncle Bob. He thinks that we don't have tests in our application, and he's right. But, okay, so we need to write some tests, because we need to have call nights, right? So let's see how the modeling everything with data paid off, because that's the final thing. You have never asked why I want to model everything with data. Now is the answer, okay? Now is the answer to the question that has not been casted. So we used data to model everything, our assumptions, our algorithms in case of censorship module, and now it pays off. But let's first think about how can we implement standard unit tests for our counting followers functionality. Remember, counting followers, we don't want to count clones, but we want to count any other citizen from the galaxy. So so those are two possible unit tests that we can write. As you see, in the standard unit test approach, we just provide examples. Example of that should be that, the result should be that. This example, the result should be that, and so on and so forth. And for this simple functionality, this isn't even the full coverage of the functionality, right? We want to have some corner cases also. So this is a very simple functionality. Remember that those are 4 lines of code of implementation, and we just have 2 tests, which is just not enough yet. So not very good, right? Creating examples is not very good. And we have a thing in functional programming, which of course is also based on the data modeling, which is called property-based tests. And it's perfect for lazy programmers, really, because what we do is we just provide a property. The property, for example, we can have several properties. One of them, for example, is that count. You can see this on the snippet of code. Count followers of clones and non-clones should be the same as count followers of non-clones, right? So that's a property. And now we just give it to the framework, waiver test in this case, to the framework, and it generates thousands of tests for us. Corner cases, big list, small list, -1 string, things like that. So we just provide a property, and the test framework will do everything for us. And of course, I can show you that in the code. This is the last live coding session, so hopefully no freezing. Presentation mode. Yes, we are in. Okay, so the test. I will write the whole test for you. Sorry, I will now write 1,000 tests. How much time do I have left? 5 minutes. Okay, 5 minutes to write 1,000 tests. We can be fine, I think. Sorry. So what we need to do is we need to provide a thing that is the. Sorry. We need to provide a random value generator for our test framework. So we need to provide arbitrary value of stormtrooper, of citizen that is clone. So this will be used by our test framework in order to generate clones, and we can use integer generator in order to do that. We are just mapping it and creating new stormtrooper, which is called clone plus ID, and the flag needs to be true. True. Okay, and now we can have also a list of arbitrary of non-clone. So here, stormtrooper, and it's a non-clone, so false. And we need to have arbitrary lists of them, so that our framework knows how to create lists of citizens of clones. Arbitrary list of clone, and the same thing here, non-clones non-clones. Okay, so that's all we need in order to set up the thing. And now we are defining the property. So property def count followers of clones plus non-clones should be the same as count followers of property. Remember, we shouldn't be taking clones into consideration, so non-clones. Thank you. And now, for all clones and non-clones, this is Java code, such that CNC count followers, now we are just writing C append all NC, should be the same as count followers NC. And now we just check it and assert that the condition is satisfied, and we just run it. And you can see here, I just have written 1,000 tests. Okay, and that's okay. So now you can see our telephone is not ringing. We can sleep happily ever after. This was Pragmatist guide for functional geekery, starring coffee house programmer, Darth Vader, Luke Skywalker, and Uncle Bob as guest star, of course, and directed by the future type, which models values that may be available in the future, option type that models values that may or may not be there, and the try type, which models potentially failing computations. All of them may be treated as monads because they have flat map operation. Special effects, ADTs, algebraic data types, which help us model more complex reality, pattern matching, which helps us work with ADTs more conveniently, and property-based tests, which help us write tests without providing any examples. And the screenplay and the code and all the problems I just described, the link to the slides, and more things are here on this GitHub account and GitHub repository. And also there is a Java and Scala applications, 2 applications implemented that are doing the same thing, and web server in HTTP, pattern matching implementation for custom types, you can see why remote data can be treated as functor, and 2 patterns from Scala, which is type class pattern, which helps us get rid of annotations in our row types, and pimp my time pattern, which helped me implement predicate logic in censorship module. So this is all you need to know in order to have this simple basic foundation for functional programming. And main takeaway from this presentation is that you should model everything as data. This is what FP is all about. I just shown you some techniques, but all other functional programming techniques are just so that we can easily model everything as data. So just a couple of techniques to achieve. And here's the reference comparison for you from the things I've shown. And the good news is that you don't have to switch the language in order to use functional programming. This is all on the link. So more advanced levels, there are some apparent differences, but other than that, you can use libraries and still be fine. Okay? My name is Michał. This is my blog and Twitter account. I work at the Codec Technology. I hope you enjoyed it, and have a wonderful second day of conference. Thank you very much.